In today's lesson, we're going to use our trig properties in order to determine some applications of right triangles. Our main goal is to determine how we can solve a triangle. And solving a triangle means that we want to find the lengths of all of the sides and the measures of all of the angles. So in triangle ABC, we want to find side A, side B, and angle B. Typically, the little letters represent sides, and the big letters are going to represent angles. And if you notice, side A is opposite of angle A, side B is opposite angle B, and side C is opposite angle C. We do know some information from our triangle. We know that angle A is 61.7 degrees. We know that angle C is 90 degrees. And we can find angle B by taking 90 degrees and subtracting 61.7 degrees and obtaining 28.3 degrees. Because we know that 180 degrees are in a triangle, and we know that one of them is 90, so the other two in combination also must be 90 degrees. We can then find side A by using our sine function, and we know that sine is opposite over hypotenuse. Solving for A, we need to multiply both sides by 106.2, and plugging that into our calculator, we obtain that side A is approximately 93.5. Now we need to find side B. We can use cosine for this one because cosine is adjacent, which is B, over hypotenuse of 106.2. Multiplying both sides by 106.2, we see that side B is approximately 50 3/10. So we know the following. We have all the sides and all the angles. We know that angle A is 61.7. We found angle B to be 28.3. We found side A, side B, and side C. Let's solve triangle DEF. Find angle D and angle F and side D. We do know that angle E is 90 degrees, side E is 23, and side F is 13. What we can do is use inverse functions to find angle measurements. So from the viewpoint of D, we know that cosine is adjacent over hypotenuse, so 13 over 23. And if we use the cosine inverse of 13 over 23, we see that the angle measurement is approximately 55.58 degrees. Knowing that, we can use what we know about right triangles and the measurements of their angles and subtract 90 minus 55.58 degrees to obtain that angle F is 34 42/100ths of a degree. Now we can use tangent of 55.58 degrees, or you could use the viewpoint of angle F. It does not matter which way. There's multiple ways to approach these. So from the viewpoint of angle D, using tangent as opposite over adjacent, we have the tangent of 55 58/100ths of a degree is equal to opposite of D over adjacent of 13. Multiplying both sides by 13 and multiplying by tangent, we obtain that side D is approximately 19. So now we have found all of our angles and we have found all of our sides. Walking at Niagara Falls. While visiting Niagara Falls, a tourist walking toward Horseshoe Falls on a walkway next to the Niagara Parkway notices the entrance to the Cave of the Winds attraction directly across the Niagara River. She continues walking for another 1,000 feet and finds that the entrance is still visible, but at approximately a 50-degree angle of the walkway. So pretend someone's walking from here, they go 1,000 feet, They look to their left and they see that the cave is still within viewable distance, but at a 50-degree angle. We want to find how many feet from the entrance to the Cave of the Winds it is. So we'll call that length C. And we're also asking to determine what is the approximate width of the Niagara River. So from where she started to the cave itself, we want to know what is the approximate length. So that's part B that we're going to identify. So we do know that this angle is 50 degrees. So from this viewpoint, we know that cosine is adjacent, so 100 feet over C. We're unsure what that length is, so we'll solve for C by multiplying each side by C, and then we'll need to divide each side by cosine of 50 degrees to get C by itself. So when I take 1,000 divided by cosine of 50 degrees, it's approximately 1,556 feet when rounded to the nearest foot. So it is approximately 1,556 feet from the entrance to the Cave of the Winds. Knowing that, we can use tangent now of 50 degrees in order to find the distance from the approximate width of the Niagara River. So tangent is opposite over adjacent. Multiplying both sides by 1,000, we see that our B is equivalent to 1,000 feet times tangent of 50 degrees, or approximately 1,192 feet. So the approximate width of the river is 1,192 feet. House framers can use trig functions to determine the length of rafters for a house. They first choose the pitch of the roof or the ratio of the rise over the run. Then, using a triangle with that ratio, they calculate the length of the rafter needed for the house. Jose is constructing rafters for a roof with a 10/12 pitch on a house that is 42 feet wide. Find the length of x of the rafter of the house to the nearest tenth of a foot. So it tells us that we have 10/12 of a pitch, which is 10 rise and 12 run. From that information, we can use the inverse tangent to find the angle of our pitch here. So tangent, because it's opposite over adjacent, and using the inverse of tangent, so the tangent inverse of 10/12, 10/12 is approximately 0.83 repeated, gives us that the angle is approximately 39.8 degrees. We also know that the width of the house at the roof is 42 feet. So when we look at the right triangle with this angle, and we look at the hypotenuse of x, the first drawing above on the top left there, the side adjacent to theta is half of 42 or 21 feet. So half of it is 21 feet. So we know one side, we know an angle, and we just happen to know that we can use cosine because cosine is adjacent of 21 feet over the hypotenuse with which we are looking for. So if we multiply both sides by x, and then we divide by the cosine of 39.8 degrees to obtain x by itself, we see that the rafter length for this house is approximately 27.3 feet. The angle between the horizontal and a line straight above the horizontal is called the angle of elevation. The angle between the horizontal and a line of sight below the horizontal is what we call the angle of depression. In Tellerud, Colorado, there is a free gondola ride that provides a spectacular view of the town and the surrounding mountains. The gondolas that begin in town at an elevation of 8,725 feet travel upward to 5,750 feet to Station St. Sophia, whose altitude is 10,550 feet. They then continue 3,913 feet to Mount Village, whose elevation is 9,500. So let's take a little picture here. So we're in town and our gondola ride is traveling 5,750 feet upward towards Station St. Sophia. So we know that Station St. Sophia is at an elevation of 10,550 feet. We want to know what the distance from town to St. Sophia is in elevation. We do know that town is at an elevation of 8,725 feet. So the elevation difference between town and St. Sophia is 1,825 feet. It's asking us to find the angle of elevation from town to St. Sophia. As we're looking up at St. Sophia, what is that angle of elevation? Since we know from the viewpoint of town, we know opposite over hypotenuse, we can use the sine inverse to identify that particular angle. So sine inverse, the opposite over hypotenuse of 1825 over 5750 gives us an approximate angle of 18.5. Now our second part asks us to determine what is the angle of depression from St. Sophia as we go back down to a Mount Village. So we need to know a few things. We need to know what is the difference in elevation from St. Sophia to the mountain. It tells us already that St. Sophia is at 10,550 feet and that the Mount Village elevation is 9,500. So the difference in elevation is 1,050 feet. We also know that it traveled a distance of 3,913 feet on its journey. So this particular angle, as we're going down the mountain, is our angle of depression. However, based on what we know about transversals and alternate interior angles, I know that this angle of depression is equal to the angle of elevation from the viewpoint of the mountain. We have ourselves a right triangle, so we can use sine of opposite over hypotenuse to identify the angle measurement, also by using the sine inverse. So when I take the opposite over adjacent and using the sine inverse, I find that the angle is approximately 15.6 degrees. Let's try one more example here. Bamboo is the fastest growing land plant in the world and is becoming a popular wood for hardwood flooring. It can grow up to 46 inches per day and reaches its maximum height and girth in one season. To estimate the height of a bamboo shoot, a farmer walks off 27 feet from the base of the plant and estimates the angle of elevation to the top of the shoot to be 70 degrees. What is the approximate height of the bamboo shoot? So we made a drawing of what the farmer is doing. Because I know opposite over adjacent and I have a specific degree, I can use tangent. So tangent of 70 degrees is equal to our opposite height over 27 feet, multiplying each side by 27 feet, and then multiplying by the tangent, I see that the height of the bamboo shoot is approximately 74 feet.